All right, the temperature was between 86 and 91 degrees Fahrenheit. This is considered a compound inequality. So let's say I call temperature T. So I know it was more than 86 degrees. So I could say T is more than 86. But then it was less than 91. This is called a compound inequality. The reason it's compound is that there's two symbols required. So some compound inequalities look like this, with the letter in the middle of two symbols. And some of them it's just it's two different inequalities separated by the word or. But this is considered an and inequality. The temperature is more than 86 and less than 91. So there's two criteria. More than 96 and less than 91. And then to represent this on a number line, I don't want to start at 0 because I don't want to go from 0 to 86. So maybe I'll just start right here at 85. Here's 90, 95. So when I put it on a number line, I'm going to do a dot, a line in the middle, and a dot. And this is a little preview into today's work. So this is the first dot, and this is the second, and they're going to meet in the middle. So here's 86 and here's 91. So this is what it looks like. All of the temperatures that are between 86 and 91 fall within this range. And that includes like 86.5, 90.3. You know, when you show it on a number line, it means you understand that it's like a continuous interval between 86 and 91. Any questions about the first compound inequality? And I have a handout for you with notes, but this is just an intro. All right, David has less than 70 community service hours, but Nick has more than 85. Have you guys started thinking about volunteer hours? There's like scholarships and things that require volunteer hours. The Key Club's a great place to get volunteer hours. Okay. So we're gonna call, service hours. So I'm gonna use H instead of X, but if you wanna use X, you can, or M or N. So if H is hours, what's the situation here with hours? David has less than 70 hours. So I'm gonna say our hours are less than 70. David is less than 70. But Nick has more than 85. So the other situation here for hours is that there's more than 85. So if it's not like David and Nick both have something in between, we separate them with this word or. They're not connected, they're not interlocking or anything. So our hours are either less than 70 or more than 85. So when you do a problem like this one, when they're quite different, a less than and a more than, let's say we start with 65. Ooh, this is a big one. Okay, so for the low end of the spectrum, less than 70, Both of these are open circles. Sometimes they could be closed circles. If only it said less than or equal to. All right, so for less than 70, that's arrow left. And for more than 85, that's arrow right. So last week on Monday, we talked about inequalities. And then we did the testing all week. And then Friday, I gave you another handout on inequalities. Today, we're still talking about inequalities, but it's a double inequality compound. And some of them are and inequalities that meet in the middle, two inequalities that meet in the middle, and some of them are or inequalities that have arrows going left and right far away. Okay? Questions about these compound inequalities? Two inequalities and one. All right, before we do anything more notes, you have two handouts that I have not really gone over yet. So get out both handouts in your binder that have inequality symbols. Let me show you what they look like. All right, this is the first one. I have not checked this yet. Carly, do you have this one? That's the one you showed me. This was from last Monday. Last Monday? Oh, okay. Longer than usual. 2.5. Okay. So for the more difficult one, here are the words and the answers. And I will go over the work if you have a request. Like if you couldn't get number one was less than or equal to 4, the word tease. But it was don't tease the freestyling dinosaur. It's feeling icy because it lost its favorite purse at a wasabi pea eating competition to a wisdom dropping inchworm. So did anybody who tried the more challenging want me to do one? Like you were working it and you could not get the answer. I don't know if you can go back and remember Friday. I saw a lot of you guys working hard on this. Let's just take a look at how to work out 7 for everybody who tried it. And more often than not, it's one sign, one negative sign that's leading to difficulties. So when I do -6 times -3, 2 negatives are going to make that a +18. So that's the first place I would check is did we write -18 or +18? -6 times +6 would be -36x. Rewrite the symbol, -38 minus 8x. And now there's lots of options. Brian, what would you do next? We could, go ahead. I think that I would either add 8x across or add 36x across. I guess adding 36 seems easier in this moment, so I'm going to add 36x, and I'm going to write it directly under the 8x. And now that's going to be gone. And I'm going to have 18 is greater than negative 38 plus 28x. And now the 18 and the 38, they're like terms. This doesn't have an x and this doesn't have an x. So now I'm going to add this 38 across to be with that 18. $56. And so now I am 56 is greater than 28x. And then I would divide, and 2 is greater than x, or rewriting that x is less than 2. So there's so many steps in here where you could probably be showing, 5 out of 6 steps correctly. But if one number gets added wrong or one sign gets dropped, it makes you feel really confused, like you've messed up the whole thing. So if you could just look step by step and say, oh, well, if I would have written, this as a positive, or if I would have kept this here, I would have had it right. So try not to just erase all your work and start all over, but try to look at your work step by step and see where you could have done something different. All right, this is the answer key to the more basic handout. In the mystery it was Billy Blue in the auditorium during third period. So I'm going to leave that one there, and I'm going to come around and I want to see both of these handouts. And if you were testing Friday, I'll discuss that with you about that particular handout. Was that your Monday handout? Oh, that was. You were talking right to the end. But you don't have the one from Monday. And you're gonna make the one from Monday. I'm gonna see. I saw you working on that. Can you see the front of yours? Okay, I saw yours. Nice. Jenny, do you want to pass these out? All right, so I hope you guys are on this side that says type 1 or. And the other side is type 2 and. Yes? Mine says type 2 and. Oh, you only have one? Who else only has one copy? Natalie, do you have two-sided? Someone must have a one-sided one. Did anybody else get one-sided? You did? What side do you have, Blair? Okay. Oh, there you go. Or inequalities have a tendency to graph apart or away from one another. It's not always, but for the most part, they go apart or away. So, for instance, x is less than or equal to -2, close dot at -2, arrow less than, or x is greater than 3, open dot at arrow 3, arrow greater. So these arrows are going apart from each other or away from each other. So if you were absent last Monday or you didn't get to the handout Friday, I'm really not too worried. I mean, because we're still working these inequalities, and these are just double the work. It's just 2 inequalities in each problem. So with the word or, for the most part, the arrows go greater, which means far away. Now, for the rest of these, we have to do a little bit of solving before we can just jump into graphing. So you just want to really think about these as 2 separate problems. And they both have their own little lines in them that you have to do inverse operations around. So for this first one, it's x minus 4. So we're going to do the opposite of subtract. We'll add 4 on both sides. And we have x is less than -3. And that one's done. And then we do the other problem. So either x is less than -3, or on the other side, that's 2 times x. I would divide by 2. X is greater than or equal to 6. And one goes this way, and one goes that way. And one's an open circle, and one's a closed dot. Do you guys need me to write down the open circle, closed dots over here? Yeah. So this one and this one, open circle. And if the line is under them, you do a closed dot. So you can rewrite that in the notes. And that was on the notes from last week, but we only talked about it, that once, and then benchmark. And then a lot of people want to write this down too. Both of these things arrow to the right because they're greater. Don't close circle symbol can split, right? If you multiply or divide by a negative, you have to flip the symbol. Oh yeah, are we on 2? Yeah. Are you with me on 2? All right, so when I divide by -3 here, I have to flip the symbol. Whenever you divide both sides by a negative, you flip. I feel like I'm writing really teeny tiny here. So this would be x. I'm flipping it from less than to greater than, because I divided by a negative. -3 divided by -9 divided by -3, +3. And then the other problem is totally different. It's not even multiplication. That's a +5, so I would -5 to get x is less than 1. So greater than 3, less than 1. Is it a positive? I put it in the wrong spot. There we go. Alright, I'm gonna pause and you guys do 3, 4, 5. I'll show the work in a moment. And finish these, okay? 5 problems. You guys finish this front. You finish the front today, we'll do the back tomorrow. So keep working. Finish the front. Don't put it away, finish it. You finish it, Jose? You finish the front? Let's do it, man. Which one do you want? Number 3? Yeah. Get it yourself. And figure it out. Yeah. You said on this is a negative figure, right? If you're multiplying or dividing by a negative. I won't see any negatives in the next 2 problems though. Did you distribute? Yeah. Yep. First you distributed property. If you got a question about the one you're on, let me know. Minus 9. You don't have to do that. Right. I just jotted this down here quickly. If it's opening to the letter, whether or not it has a line in it, if it's opening to the letter, your arrow should go right. And then I'll scroll. Whereas if it's, and I kind of messed this up, let me do better. Whereas if it's not opening to the letter, if it's opening to the number, your arrow should go left. So you can write those 2 down and kind of refer to it. It's kind of like you gotta maybe it would help if you had a highlighter. So I'm gonna put a highlighter where the or is, but the line for the symbol goes underneath there, like the equal line, but it's an inequality line. So here, when I subtract 9, I'm doing it on both sides of the, and then on this one I would subtract 10. So if anybody has any questions, direct them to Brian. He said, no, divide 2. You have a question, Brady? Yeah, good job. I'm gonna check it. It was 9. Let's see. No, because 10 take away 10, 0. 0 divided by 5 stays 0. I know zeros are tricky. 0 divided by anything just stays 0. 0 comma. I'll show you the words for that. We continue. Continue to the next step. Yeah, you do. Where is? Didn't you have one before?
Yeah, but I'm looking at the house.
Oh, okay. So hard when everything gets moved around. Okay, so yeah, I end up with 0 divided by 5 is 0. So I'm going to have an arrow right for the 4, open circle, and an arrow left at the 0, open circle. How'd it go? Anybody get it right?
Yeah.
Couple people. Good. Next one. Okay, just want to cancel like that for here. I'm not going to go over interval notation even though this handout says it. I don't think it's necessary. I cover that in algebra too.
Oh.
Alright, finish these last two. I'm going to show the answers tomorrow. And then we're going to start working on the back. If you want to start the back early,